Hello, my name is Jemael Nzihou. I'll be presenting the data-driven process improvement for manufacturing. The goal is to optimize the manufacturing efficiency through the DMAIC method using Minitab as a tool as well as Tableau. And on the right-hand side, that's just me when I was working as a process engineer at Leonardo Electronics. So the agenda is here. We're gonna get to the introduction, define what the DMAIC framework is, which basically define, measure, analyze, improve, and control. So we're gonna also look at the case study, what impact that it has, and then we're gonna visualize it through Tableau, and then how the process has been improved, and then we're gonna point out on the different application, and then also the key factors, and then take away, and then conclude our presentation. So on the introduction, what is basically like the role of a manufacturing process engineer or industrial engineer? So basically the role is to collect enough data points or procedure in order for the quality of the process to be optimized, basically. So improve basically the process through, you can think of the workload, the manpower, and then the shift, the delivery time. So that's basically the role. And then the approach here will be using like the Six Sigma DMAIC method for process improvement. And the tool will be Minitab, which is also like a statistical process analysis, and then also Tableau for visualization. And then on the left hand side, that was one of the tools. We were actually measuring one of like the wafers that I was working on. So that's basically that. And then the next, we define like the framework, the DMAIC framework. So on the defining, so we have to identify what the production network bottleneck and defect is. So when we have the quality, like let's say the wafer, so the production of the wafer, basically we encounter defect. So we have to define those measurements based on what the customer needs. And then the measurements, the measure phase, basically we collect the baseline data on the cycle time, the yield, as well as the defect. So we define basically and measure those elements, because if we don't define it, we won't really know our limits. Yes. So, and then after the measure phase, we go to the analyze phase, where we look at the root cause analysis and then the process capability studies. So that's where we focus on what was the issue, what didn't work, and what was actually the key factor on the analysis. Once that's compiled and then found, so we can actually now improve to implement solution to reduce like the waste, as well as improve like the efficiency of the process, basically. And then once that's done, then we can actually control by maintaining the improvement through the SPC, specific process control monitoring. So on the defining phase for our specific goal here, the production inefficiency had high defect rate. So our goal basically was 50% cycle time reduction and then 10% defect reduction, which was actually perfect for this presentation, basically our case. So on the measure phase, we look at the cycle time, the defect rate, and the material usage. So on the left-hand side, we actually scribe the wafers. So that was as we were scribing it, so we encountered some defect, but we also use like the machine to collect the time, and then also based on that, we were able to look at the defect rates on the number of like wafers that we use. Basically, if like we wasted some material, how much was that? So that was actually how we were able to measure our quality product. And then the analyze phase, as I mentioned, we look at the root cause analysis. What was the major issue? In our case, the major issues was actually the procedure, because the operators had hard time to follow procedures. So I had to go on the floor, basically like speak with them and then find a common ground where we could actually look at what was working for them. And then as a result, we rewrote actually the procedure that fit everybody. And then as a result, we improve actually. And then I also use the Pareto analysis to get to that. But basically, the Pareto analysis is basically a technique used to define actually 80% of the problem caused by the issues that's been experimented in the workforce, basically in our case. And then the process capability was actually the way to actually see if there were like deviation in the process and if the process was capable to produce quality product. And with that, we look at key KPIs, basically like such as like CPK and CP, which we will actually define later on. So on the improve phase, we look at like the workflow redesign to minimize basically our bottleneck. And then we also look at the automation, which was, the material handling, how we could actually better use our material, as well as designing like the experiment better using Minitab. On the right hand side, so one of the example was actually fixing the environment. As you can see on the top picture, we had a lot of things, actually a lot of items on the floor, but at the bottom the floor has been actually reorganized and more neater. So as you can see, for safety purposes, like people walk around and stuff like that, so that can create issues in the workplace. So that's why it has been improved in this case. And then once that was done, we were able to control actually using the SPK charts to monitor the quality, such as with the X bar chart in Minitab, and then the standard operating procedures, as I mentioned, for sustainable improvement. And then for the case study, so my role basically as a process engineer was to actually conduct some analysis on the production so that we could find actually some better methods to improve the yield. And then as a result, after modifying the procedure, we actually came to conclusion that there was an impact. After rewriting like the procedure, we reach a 10% cost reduction, which saved and achieved a minimal rework, because the operator were actually satisfied with what was working and then what was not working. So that was actually one good impact. And then on the material saving, we observed 15%. So which was actually like waste reduction, which led to basically like a substantial saving in our department, which was actually a good sign. And then we had a 20% time efficiency, because if we improved like the quality of the procedure, which enabled actually the operator to work better and then function, which as a result, it actually improve our quality product. So here we have the data visualization using Tableau, as well as dashboard here, DMAIC dashboard. So on the visualization, the goal was basically just to map the key performance, like the KPIs, to clearly define what the problem was. And we mentioned that it was actually the procedure, and then with the operator, and then we create the dashboard displaying the process data, including control chart, histogram, and the scatter plots to understand the current state of the procedure. In the analyze phase, we use Tableau at the bottom right hand corner. So to kind of like just, look at the analytical features like regression analysis and correlation matrices to identify the root cause. And on the improve phase, we wanted to track like the impact of the implemented improvement by visualizing the changes in key metrics over time. And then to conclude with the control phase, we monitor actually the post-improvement process performance through the dashboard in real-time updates, which was actually really beneficial. And then what we observed, we had like a faster problem solving, the data-driven decision making, which was actually linked to our data, and then we made better informed choices based on our visualization. And then we improve our communication by interacting with the stakeholder during engineering meetings. And then also through the collaboration, we also facilitated like the data sharing team, because I was working with the manufacturing lead, so he actually provided like the data for me to conduct the analysis and then present that to the group. And then also for the continuous improvement, so to just track the progress and maintain improvement over time. So you will be wondering like, okay, why do we even care, and then how is that applicable in the real world? Well, the DMAIC principle apply across various like industry streamline to enhance like quality and boost productivity. So one example would be in manufacturing. An example was me working as a process engineer to improve that. And then second was the healthcare. So you can apply that in healthcare as well as services and then software development. And then I think the picture on the right hand side illustrates that much better. And then the key factor, how did we know, was basically, our CPK and then CP was actually greater than 1.33, which was actually a good indication that our process was capable of achieving quality product. And then here at the bottom, we see like a Minitab screenshot for the process capability report, basically. And then we also look at the p-value, which is basically like a statistical like elements to help us assess the differences in performance. And then if like the variation was made based on the real issues, or the real change, or the random, basically. So usually we look at the p-value. If it's less than 5%, that means that it was statistically significant, and then we reject the null hypothesis. If the p-value was greater than 0.05 or 5%, so it was not significantly it was not statistically significant. So we failed to reject the null hypothesis. And then the key takeaway here, basically, it's like, we enhance the manufacturing efficiency by minimizing the errors and maximizing the output through data analysis. So the use of data was actually key. And who used that? Well, I did use it in a manufacturing setting to improve basically, the process. And how was that done? Through the DMAIC method, using Minitab as a tool, as well as Tableau to drive, our insights. And then we can use that in different sectors, such as, healthcare, to impact like production. And that concludes our presentation of today. And then this is basically the time for question And then thank you very much for allowing me to present, and then thank you.